So if you guys look immediately, what you should see is some sort of ball contraption-like thing, right? Which has a cable to it, which travels some distance and finally hits that plate on the right there in the gray. That's gonna be called the trip plate, right? And I'll explain in a second what that is. But if you guys wanna bear with me as I walk around, this experiment, what you would necessarily do is have some remote trigger which would release this ball, allowing it to travel some distance, and it would smack this trip plate here, right? So going through that one more time, you would have some sort of remote trigger, right? Which allows you to release this ball, and the ball is going to travel some distance, and it's going to land on this plate, all right? Now, what's really important to remember is that even though you're sort of using a remote trigger to release this system, right? This release for the ball, as well as the trip plate, are actually connected and tie into this cable here, right? So if you had some remote, essentially what that would enable you to do is at time 0, you would press that trigger, right, that remote, it would release the ball, starting some timer, right? And then at some time after, when it hits the trip plate, the top of it, right, it stops that timer. So that gives you the first variable of time. Now, as you probably can guess, the next variable we're gonna be measuring is the vertical distance, right? So a few things with this. I'm gonna try to preach it to you guys all semester, but as experimenters and as students, you're gonna be the one that's setting up the guide of what the vertical distance is, what axes you're gonna be working with. Sometimes it's out of convenience, sometimes it's just up to you. So in this particular case, what you might notice is that our starting point is actually gonna be your 0 point, right? So as the ball drops, you're actually gonna be gaining a positive distance. If we were to flip this around, right, the only difference would be, it would be gaining a negative distance or a negative displacement, all right? And so you might notice your vertical displacement or your vertical axis is gonna be fixed, right? So you can basically measure that once and you're gonna use it over and over and over. But what's gonna change is the time or the duration in which the ball falls. It might be 3 milliseconds. It could be 4 milliseconds the next time, maybe 3.5 the time after that. And the idea is if you have a vertical distance and then you have your time, then you should, in theory, be able to calculate so-and-so on your equation, right? Now, it should probably go without saying that because we're measuring a vertical distance or displacement, you want to make sure that your ball is perfectly vertical with your meter stick in which you're measuring. So if you had some setup like this, where your meter stick is at an axis or at some angle, you're not getting the true value of the height in which the ball is falling. The same could be said in a situation like this, where your meter stick is totally slanted, right? Now, in the actual experiment, when you do this in class, it doesn't even need to be a huge distance or a huge sort of shift in or tilt in the angle, right? That can cause a huge change, right? So just be careful that anytime you're doing an experiment, right, make sure things physically make sense. One other thing you want to keep in mind during this experiment, which could be a huge source of error, is that as this ball drops, it's going to fall and it's going to hit our trip plate down here. Now, you would have a huge source of error if for some reason this was messed up and it didn't actually measure the time until it got to some point below. What I mean by that is the time you're measuring, as well as the height you're measuring, is going to be from the bottom of the ball. So let's say your bottom of the ball is at 0 here. Actually, the meter stick is flipped around, so on the other side it's going to read 0. But let's say you press the remote trigger, it drops from 0. It better be measuring the bottom of that ball, all right? Something else that's important to mention is that it's going to be stopping the time when it hits the top of this so-called trip plate. think there's a question on the post lab that may or may not ask you what the error or what the effect would be. It's if instead of the ball stopping or the timer stopping during this experiment at the bottom of the ball, it was allowed to travel some smaller distance below that, right? What would that do to the time? What would that do to the height? And how would that ultimately affect what your measurement or your determination for the value of gravity is? So those are just some things to keep in mind, all right?